This notebook covers future scaling, encoding, selection, creation, PCA, and best practices with practical code snippets, and interview focused exercises. Imports and setup. We import NumPy, Pandas, Matplotlib, Seaborn, and silent warnings. Key concepts which we are going to learn. Scaling. In scaling, we are going to learn standardize, min-max robust, min-max or robust, encoding, polynomial features, select k-best, RFA, variance threshold, explain what to pick each, when to pick each, scaling for gradient-based models, robust for outliers, one hot for nominal categorical, ordinal encoders for ordered categories. Emphasize mapping concept to when to use and why. Implementation samples. Code. In this session, we move from toy data to practical feature engineering patterns. Here, in this code, first we started with make underscore classification function to create a dummy dataset. By using this function, we created 1000 samples, 20 features, 15 information. Then, we tried to split the data into train and test. This demonstrates reproducible pipelines. Future scaling examples and visualization. Here, we created a sample data frame with every squared income, age, credit score. Then we applied standard scalar, min-max scalar, and robust scalar. And we have plotted original stats and shows histograms for income across scalars to inspect the data. Standard scalar. Standard scalar, zero mean. Unique variance, good for normally distributed futures. Min-max scalar rescales to 0 to 1. Preserves distribution shape. Robust scalar uses mean and IQR, reduces outlier influence. Extreme skew or outliers change the choice of scalar. Now, we will cover encoding strategies for categorical variables. Code. Here we are going to discuss label encoders, one hot encoder, ordinal encoder code. First, we created a dummy dataset which consists of columns such as color, size, and price. We demonstrate label encoder for single label transforms. By using pg.getDummies, we get one hot, we perform one hot encoding, an ordinal encoder where there is an order size equals to small less than medium less than large. Key points. Label encoder is simple, but we can introduce ordinal if used incorrectly. One hot increases dimensionality, means mention scarcity and when to use target encodings or embeddings for high cardinality features. Multi-feature selection methods to reduce dimensionality and improve performance. Here, we create synthetic classification data and demonstrates select k-best to pick top features by ANOVA. Let's score RFE with a random forest classifier for recursive elimination using estimator importance, variance threshold to drop near constant features, and finally random forest feature importance plotted to inspect top predictors. Select k-best, fast, filter method independent of estimator, RFE, wrapper method considers estimator interactions but slower, variance threshold, simple, heuristic, useful early, model based importance, intuitive, capture interaction but independent on model bias. When to use future versus filter versus wrapper versus embedded methods, runtime and interpretation trade-off. Now we demonstrate feature creation, polynomial interaction features and domain specific time features. We use polynomial feature degree to create interaction and square terms for small feature sets. Then a domain example, extracting year, month, day of week, and a weekend flag from a day index to show how time features can boost predictive power. Ex- uh, then a domain example extracting year, month, day of week, and a is weekend flag from a day index to show how time features can boost predictive power. Pre-processing inside pipeline or column transformer to avoid leakage. Best practices. Always we have to split data before pre-processing. We have to use cross-validation for evaluation. We have to monitor overfitting and underfitting. We have to get the best hyperparameters by using hyperparameter tuning. We have to start simple and then add some complexity. Concepts covered in feature engineering are feature scaling, feature encoding, feature creation. When used, when should you apply these techniques? Apply when you need it is when you want to reduce the dimensionality and extract meaningful patterns from data. What are the common challenges? Overfitting, complexity, computational complexity, hyperparameter tuning, and interpretation of results. These are the practice exercises. Implement the same core algorithm from scratch. Instead of directly importing the libraries, try to build it and try to implement that in dataset, other datasets, real world datasets.